Hey everyone, this is FixReef, and today we have another EB832 up for repair. This one came in from a previous repair attempt, so we do not know what we're going to find inside. The issue is that the customer attempted to upgrade the 12-volt power supply, something went wrong, and it would not work from this point on. So the request is to try to get it to work again and upgrade the 12-volt power supply as well. First, we're going to plug it into power and just see what kind of LEDs come up. It's currently plugged in, and there is absolutely no lights, LEDs, anything coming up. So this is as dead as it gets. I'm going to flip it over, make sure that everything works. Everything is... While the lights are not on, I can hear the relays clicking on the inside. So something's alive, just no sign of life on the outside visually, but something's on inside. I think I can also hear the fan spinning. So not everything is lost yet. So let's take it apart, see what it looks like on the inside. Okay, I was expecting perhaps some connectors disconnected off of the front LEDs here, maybe the ribbon cable or something else, but it's mostly all on. Notice the type of the wire for the fan here. Some models, some revisions of this model, I should say, have this quick disconnect on this end for the fan. It's not often that I see this. Okay, so now that we have it out, or we have it open, let's take a look at any power LEDs on the inside that come on at all. Plugged in. Okay, so the 24-volt power supply is not working. You can see that the green LED is not on. The 12-volt power supply seems to be on. You can see the red LED inside there being on, and that explains relays clicking, so it does provide power. But it seems that the capacitors are different on this one. We'll see. We may have to upgrade the 12-volt power supply as well. But the bigger problem right now is that the 24-volt power supply isn't working. And because the 24-volt power supply is not working, that explains why none of the front panel LEDs are on. Because if you remember from some of my previous videos, and if you haven't seen those, check them out. The 24-volt power supply is also responsible for providing 12 volts to the Aquabus ports, and 12 volts to power the LEDs over on the front panel. So the big guy is not working here. None of it is going to work either. So we'll have to figure out what's wrong with the 12-volt with the 24-volt power supply first before we move on with this repair. So let's disconnect the front panel entirely. And take the main board out of the case. And of course we have the glue inside the screws. I honestly do not understand the purpose of this. If this was put in here to prevent me from taking those screws out, it slows me down, but it's not going to prevent me from getting the repairs done. If this was put in place to keep the screws in place so they don't come off, clearly that's not the right way to do it. Okay. Let's check the back of this card of the unit. The 24-volt power supply looks very good. If you remember in one of my videos, this when it was, I think the 24-volt power supply got water damaged. This whole area here was black. Clearly there was some short that caused a massive burn out area here. So that's not the case here. We'll have to see what actually failed. Also, I'm not sure how much you can see, but let me see if I can zoom it in. But the controller area over here had some work done on it. I believe from what I've heard the customers say about this unit is that it was previously sent in to Neptune for repairs, or they've received some kind of refurbished unit. So when you do send those into Neptune, and they do come back refurbished. Who knows what was done to them and to what extent. Anyway, so I'm not sure if this whole area is working, but before we do anything, this requires 24-volt power. And this requires less than 24-volt power, but the power provided to this controller is coming ultimately from the 24-volt power supply, which is currently not working. So let's find out what's wrong with the power supply. All right, first, let's make sure that we have AC power coming in. 120 volts. Very good. Clearly, if we attempt to capture power on the output, it should be nothing. And it is. All right, let's get ourselves again familiar with the 24-volt power supply. There is a high voltage side that's on this side of the power supply, and the low voltage side is on this power supply, right on this side of the power supply. Here in the middle is the big transformer that handles quite a bit of load on the DC side. Bridge rectifier. There should be a small fuse, which I would like to test as well. A big capacitor, a couple of smoothing coils, and more importantly, a power MOSFET over here. So this power MOSFET fails often. If the fuse is blown, which is here, that would indicate a problem elsewhere. A fuse is just the beginning of the problem. So let's find out first if that fuse is actually blown. So the fuse is over here. These two pins is the fuse. The power comes in, goes over this fuse, and then on the other side goes around to the bridge rectifier. So we better see 120 volts on this side, just like we did before, and then 110 volts over on this side of the fuse. Okay, so once again, 120 volts coming in, 120 volts entering the fuse, and 120 volts coming out of the fuse. So the fuse is good. Now let's test the MOSFET. Okay. Okay, so on the first glance, the MOSFET appears to be fine. Okay, the most basic components have been tested. Now we'll get to do a little bit more advanced testing of this. The next thing I'm going to do is test the bridge rectifier. So it's supposed to receive 110 volts coming in. So 120 in this case. So there's supposed to be 120 volts coming in. 22 AC coming in. But 22 AC is not 122. And it's supposed to produce DC voltage. Very rough DC voltage, but nonetheless DC voltage. and it's not producing anything. On the DC side, it's not producing anything. So either the bridge rectifier failed, which does happen, or something else happened. Oh, and now we don't even get AC voltage on it. Okay, so either short on the bridge rectifier or power that comes into the bridge rectifier. Okay, so the next thing I'm going to do is I'm going to test the rectifier diode, the one that converts AC to DC voltage, to make sure that it's working, because the voltages are odd and it's possible that it's shorted. Alright, so my negative DC lead is here, so we're supposed to get about 500, oops, test, 500 millivolts between DC and AC, DC and AC, that's looking good, and from the positive, that's also looking good, and that's looking good. Now, the rectifier is good. Okay, so what else is wrong? Continuity here is good. Continuity here is also good. There is no short across this. Doesn't look like a short across these two. This is good. But this isn't. So this coil is good, but this coil is not good. Wow. This is one of those very rare cases that it appears that the inductor is blown. Wow. Not the fuse that's supposed to blow, but the inductor. Look at how thick the inductor wires are over here. And it appears that this inductor is blown. That is very surprising. Here's an example of a working inductor. It's a different inductor from the one installed here, but just to show. Obviously, if we have this set of wires, there is continuity, and we have the other set of wires, there's also continuity. However, if we look at this inductor here, there is continuity here, and there is no continuity here. Okay then. We are going to take this inductor out and see what it looks like. So to take it out, my suggestion to those of you who are trying to work on this, notice that I'm not using the microscope on this, because everything is fairly big. So when you work on something that big, to help you take components out, they're originally made with unleaded solder that requires higher melting temperatures. To help get things out, add quite a bit of leaded solder, let it mix and penetrate. What that's going to do is it's going to lower the overall melting temperature and will help tremendously in getting the component out. So this inductor is covered in glue again. So we're going to have to help it get rid of some glue. It's not going to be straightforward because it's not, well, it's not as bad as the one that I've repaired in my other video, the 24-volt power supply. There is still quite a bit of this white glue, so we'll take some of it out. We don't have to replace this. Again, this is a generic power supply that Neptune chose for this EB832. The reason all this glue is in here is because in case this gets installed in a unit where there is high vibration, say it's installed in some kind of machinery, then you want to make sure that vibration doesn't kill and doesn't make the components come off. When it's EB832, you don't have to worry about vibration as much. There are so many other problems that these EB8s have, that vibration is the least of those worries. I am genuinely curious about what exactly happened to this coil, to this inductor, because the rule is in repair is that it's never an inductor. Those just don't fail, primarily because of them being quite simplistic and not having any sensitive components in them. It's basically just a coil of copper wiring. And as long as that coil is thick enough, like in transformers, copper is thin, so it may burn out. But in inductors, this does not burn out as much. All right, let's see if we can force this guy out now. And we're out. See how similar it is to the one that I have here? It's not going to be identical. It's not going to be a direct replacement, but okay, let's test it again. Okay, continuity on this coil. No, it has continuity on both of them. Was that because of the bad connection somewhere on the board? Okay, so what I'm going to do is I'm going to just quickly connect it to this side of the board, just for testing purposes. Okay. Let's plug it in and test. I'm going to flip it over on the other side to see what we have with the green LED, because maybe my angle was not as good and the LED is actually on. And look at this. The LED is on. So the coil was not fully seated and was not fully soldered to the board. Again, guys, it's never the inductor. In this particular case, it was less than ideal soldering. Okay, we'll take the coil off, clean everything up, install the coil as it's supposed to be. And make sure that it's going to be installed properly. So to complete this repair, I'm going to have to clean up the area where the coil goes in. Again, I have shown this trick before, but once again, I'm using this wick, and I'm not happy about this wick specifically because that's the one that I'm trying to use up, but for the purposes of this larger components, it's going to work. Let the heat do all of the work for you. The heat and copper is going to absorb nicely any solder that's in here and clean up the work area. See, all you have to do is just wait for the heat to melt the solder and then let the solder flow towards the wick where there's plenty of copper, and it just absorbs everything and makes the whole area nice and clean. Alright, so all of this old solder is gone. I will need to position the coil and make sure that all 4 wires of that coil are connected properly. Sometimes what happens with these coils is that see that the wires that are on this coil, the copper wires, are kind of loose. You can move them, you can remove them if you want. When you press all 4 of them into those tiny holes, they may not go in easily and may resist. So I'm guessing what happened in this case is that it resisted enough that it barely connected to the other side. It made the connection maybe in the first, attempt, and then as somebody tried to move it, it failed and got disconnected. All right, let's put it in. This is also going to be tough because I'm going to reuse this coil, but the wires are all so short. So one way to solve this is to align the pins on this side first. Make sure that all of them are positioned well to go into these holes. And then just flip it over on the other side and it should just go right in. Okay. 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 2 pins are in. Okay, so once I have all right, so while I have one side of the coil in, I'm gonna need to secure it so it doesn't come off. And then we can worry about the other side. Making sure that there is nice and long leads coming out. That way we know that it's gonna have a nice connection. Okay, that looks really good. Now we just need to attach the other side. Okay, so the coil is back in place and all 4 pins are sticking out pretty well and soldered pretty good. Let's clean it up. Flip it around and see if it works. Alright, so we're watching the green LED on a 24-volt power supply. Okay, looks like the LED is on, and there's a chance that this EB832 is going to work again. Now that the LED is on, before we reassemble, we're going to attach the front panel. Make sure that the at least the Neptune LED on the front panel is going to turn on. Okay, and the Neptune LED is blinking. Good sign. All right, and the last thing we're going to do is upgrade the 12-volt power supply as well. It's been a while since I've shown how to do the upgrade, so I'm going to go through it again. Okay, so again, this unit came from a subscriber. And by the way, thank you to all who subscribe to this channel. There will be a lot more great content coming. But this particular subscriber, he suspected that the issue with this EB832 was the 12-volt power supply from the beginning. Again, this was a prior repair attempt. So he sent me this 12-volt replacement power supplies that he ordered off of either Amazon or AliExpress or some other vendors, and asked me to replace those. I'm going to quickly go over why that's not a good idea, but first let me take out the original power supply here. So again, to take out the original power supply, the easiest way to do this is to apply leaded solder to all 4 pins and push it down. Generously apply to all 4 pins. And now, just heat up 2 pins at a time. And it drops right down. Once that's done, do the same to the other 2 pins. And it comes out. All right, so we will clean up the area later. But first, let me talk about the power supplies. So this is the power supply that came with the EB832. This is the replacement power supply. They certainly look identical, don't they? But because they look identical, that is actually a problem. The reason is, let me zoom it in. The reason is because of this because of these capacitors. These capacitors usually blow, and when they do, these are cheap Chinese capacitors. Typically, these 2 capacitors on the DC side blow quickly. This capacitor over here and this capacitor. When these capacitors fail, they also cause the power supply to fail. So when we take this probably was originally taken out of the EB832, or maybe I don't know, because this is the original Chinese capacitors that I see often. These capacitors are a different company, but they are also cheap Chinese capacitors, so they're not much better. So when we replace one bad power supply with another equally bad power supply, we are not solving the problem. We are temporarily solving the problem until capacitors on the next power supply fail. So instead of replacing the power supply, we are upgrading the capacitors here. So once again, here's how it's done. I'm going to use this power supply to show, primarily because it already has these pins connectors and pins connected to it. Other power supplies don't. So here's what we are going to do. I'll use my holder to hold this in place. Now I'm going to apply leaded solder to all capacitor pins that we have here. And I don't have to worry about bridges at this point because all of this is going to be fixed later. Now the goal is to get the capacitors out. Now I can just use my soldering iron to gently heat up both pins at the same time as the capacitors just fall out. That was number one. This is the hardest one because it's got some other components next to it, which we don't want to damage. So minimum heat as fast as possible, get it out, move on. So again, this inherently is not a bad power supply, just the capacitors are bad. Next, we're going to clean up the area. Again, I'm using the wick to take away all of the solder that we just used and added and it was in place there. And the best way to do this is just to let the heat do all of the work for you. This one we have to perhaps try from the other side real quick as well. Okay, we cleaned it up as much as we could. Now we just need to get the capacitors. Okay, first we need to get one of these guys. Then one of these. And finally, two of these. Okay, let me show the difference. So all of these new capacitors that I have, they're all Japanese capacitors that are of highest quality available. Rubicon, another Rubicon, Nichicon, and probably another Nichicon. Okay? These are the capacitors coming from the power supply. Luan, Chinese, Aishi. Aishi, I believe, is also Chinese, made sound like Japanese capacitors. So these capacitors are typically found in higher-end electronic components, electronic units. They will not last forever, but they will last long. Whereas the Chinese capacitors, if you're lucky, they will last 6, 7, 8 months. All right, so now that we have capacitors picked out, let's flip the board over and install them one at a time. Because I didn't do the best job cleaning out the holes, we may have to heat up the pins slightly so that they go in. And see also how nice it is with the holder. You don't need for it to jump around the... Of course, when you install them, you have to maintain the polarity, or otherwise they will not work. Okay, all of them are in place. We'll flip it over again. All right. We won't need the holder anymore. Okay. So now we have all of the capacitors upgraded, and this power supply should last much, much longer. It's time to reinstall it. before we reinstall, we need to clean up the PCB here, because otherwise the new or upgraded power supply is not going to go in. Again, letting the heat do all of the work. See, all 4 holes are now nice and clean. Let's make them even cleaner. And let's reinstall our power supply. Now that the holes are clean, reinstall is extremely simple. Just need to plug it in. And now just solder it in place. One last cleanup. And we're ready to test. The green LED is on. The red LED is on. Both power supplies are working. Let's reassemble and do some final testing. Okay, so for our final testing, we're going to change things up a little bit. Let me make sure that you can see my load tester. So we're going to change things up a little bit, and I'm going to change the 12 volt and the 24 volt output of the of this EB832, just to make sure that, because we were making changes to the power supplies, we need to make sure that both power supplies are capable of handling the load that we are providing. So first, I'm going to test the Aquabus output. So Aquabus is producing 12 volts. Let's give it a load. Keep it about 350, and it's capable of producing the 350 milliamps of power at 12 volts, so that's pretty good. Next, I'm going to test the one-link 24 volt output. Let's use this. So this is producing 24 volts. Let's give it some load. And it's behaving under load. At least at this point, it's producing a pretty good, almost an amp of power. We can probably ramp it up a little bit higher. Okay, so the 24 volt power supply is holding up, and you can see that the 12 volt power supply is producing enough power to switch the outlets as well while we were waiting. So behind the camera, I'm going to plug this EB832 into my head unit, make sure that it all can talk to the Apex head unit, can switch the outlets, can work properly. But for now, this completes the repair. Thanks for watching. If you enjoyed this video, please like and subscribe, and I'll see you next time.